Welcome to this video on solving linear equations. Now we've had a bit of a look at linear equations in the past and we've seen that they take the form of something like this, where we have an unknown and different operations are happening to that unknown, and it might be equal to something. Okay. Now, solving means to find the value of the unknown such that the statement or the equation is true. Let's have a look at these two examples. With these two examples, we're able to solve them numerically or via intuition. In the first one, we've got something plus 2 equals 7. Now we can see just by going intuitively or using common sense that something must equal 5. We can do a check. If we say 5 plus 2, that equals 7. So that's correct. Okay, with the second example, we can also do that intuitively. 5 times by something equals 30. Therefore, that something must equal 6. We can do a check. We can go 5 times by 6 equals 30. The left-hand side and the right-hand side are equal. So that's looking at solving linear equations through a numerical process or via common sense or trial and error. What we're going to have a look at in this video is how to solve linear equations using an algebraic technique. In the past, you've looked at an equation like it was a set of scales. So we have two sides to the scales, and the scales need to be balanced. So they need to be even. So whatever we place on one side needs to be equal to the other side. So let's just see. Let's imagine we have two boxes and they have a value of X, and then we have three balls and they have a value of 1. So on the left-hand side, we have 2x plus 3. Now on the right-hand side, let's say we have 7 balls with a value of 1. So that's saying that this set of scales is balanced and is equal to, we've got 2x plus 3, and that's equal to 7. Now, in order to work with this set of scales, in order to find the value of 4x, we have to make sure the balance stays even. We can't take more off one side than the other because the set of scales will get out of whack. They won't be even anymore. So we have to work between both sets, and whatever we do to one side, we have to do the other. So the first thing I'm going to do is I'm going to take off the 3 balls from the left-hand side, because that will leave me with just the x's. That means that I have to take off 3 balls from the right-hand side. So we're going to take 3 from both sides. Okay. Taking 3 from both sides leaves 2 x's on the left-hand side and 4 balls on the right-hand side. Now, because we've done the same thing to both sides, our set of scales is still balanced. So our equation is still balanced, even though it now looks a little bit different to what we started with. Now we've got to ask ourselves, how do we get to just 1 x on the left-hand side? We've got 2 x's there. If I take those 2 x's and divide by 2, that will leave me with 1 x. But remember, with our set of scales, we've got to do the same thing to both sides so that the scales stay balanced. So what we're going to do is we're going to divide both sides by 2. When I divide both sides by 2, that leaves me with 1x on the left-hand side and 2 balls on the right-hand side. So for our equation, that must mean x is equal to 2. So that's thinking about it figuratively with a set of scales. Let's now take that same equation and think about it algebraically. So if we start off with 2x plus 3 is equal to 7. Now we're aiming to get the x on its own. So the first thing I'm going to do is get rid of that 3. But remember to keep things balanced. Whatever I do to one side, I do to the other. So on the left-hand side, we now have 2x plus 3 minus 3, which leaves 2x. And on the right-hand side, we have 7 minus 3, which leaves 4. Now we need to get that x on its own. And it's being multiplied by positive 2. So to undo that multiplication, we have to do the opposite of our operation. So we're going to have to divide by positive 2. So do we divide both sides by positive 2? We get x is equal to 2. So it's the same answer as we found using the balance, but this is how we're going to solve things algebraically. Let's have another couple of goes at a couple. Okay, let's have a look at this first example. We've got 4x minus 5 is equal to 7. So our aim is to get that x on its own. So we need to start removing things from the left-hand side. So the first thing I'm going to remove is this negative 5. We have to do the opposite operation to remove the negative 5. So I'm going to add on 5. And remember to keep the equation balanced, we have to do the same thing to the other side. So on the left-hand side, we get left with 4x. And on the right-hand side, we get left over with 12, because the 7 plus the 5. Now, to get the x on its own, it's together with the multiplying by 4. So we have to unmultiply. So in order to unstick that multiplication, we're going to have to divide by 4. And remember, we have to do it to both sides. So we get x is equal to 3. Let's do a check. Let's make sure that we've found the right solution. Okay, so we have 4, left-hand side, 4x minus 5, 4 times by 3 minus 5. And the right-hand side is equal to 7. So the left-hand side is equal to the right-hand side. So we've found the correct solution. We've found the solution that makes the statement true. Let's have a look at the second example. We've got 5 minus 2x is equal to 7. So the first thing we need to get away from the 2 is this 5. Now you've got to remember there's an invisible positive in front of that 5. So to take that 5 away from the left-hand side, we're going to have to subtract the 5. And we're going to have to subtract it from both sides. So on the left-hand side, after we've subtracted the 5, we're left with negative 2x is equal to 2. Now, we have to look at that x now. We've got to look at it, get it on its own. What is it stuck with? It's not stuck with a subtraction of 2. It's stuck with a multiplication of negative 2. So to get rid of it from the x, to take it away from the x, we're going to have to divide by negative 2. And we're going to have to do that to both sides. So negative 2 divided by negative 2 gives us 1. So we get 1x on the left-hand side. And then on the right-hand side, we've got 2 divided by -2. That equals -1. So our solution for this case is x is equal to -1. Let's do a check. We'll substitute it in and check that we got the right answer. The left-hand side was 5 minus 2x. So we have 5 minus 2 times -1, which is 5 plus 2, which is 7. And on the right-hand side, we have 7. So the left-hand side is equal to the right-hand side. So the solution we've found is the true statement. Okay, another way of solving using algebra, but not using it step by step, is to solve linear equations graphically. Now we can do this if we have a picture of the linear equation. So let's look at this example to start with. We have some linear equation. It's a straight line, which makes it linear. And basically, along this straight line, we have lots of pairs of x's and y's. So we can solve by finding the pair on the line. So let's solve to start with. Let's solve for y when x is equal to 1. So let's find the value of y when x is equal to 1. So what we have to do is we have to go along the x-axis, find x equals to 1, and then find the point on the line that corresponds to that. Now we're lucky here because the point that corresponds to that is when x equals 1, y equals 0. So that's the solution for this particular case. Let's have a look at solving for x. So solve. Let's try and solve for x when y is equal to 1. So what we have to do is go to y equals 1, and we come across to the line, and we find where it hits on the line, and we then draw an arrow down to the x-axis, and that's our x solution. So when y equals 1, x is equal to 2. So that's one way of solving graphically. We'll now look at one more way to solve graphically. Okay, here's an equation. Now it's actually the graph of y is equal to 2x plus 1. So what we're going to be able to do is solve varying combinations of 2x plus 1. So let's solve this equation. 2x plus 1 is equal to 11. Basically, what we're saying is solve for x when y is equal to 11. So let's find y is equal to 11 on the graph, and then we'll be able to solve for x. So here's 10, so here's 11. So this is y is equal to 11 at that spot there. Now we draw an arrow, a line, across to our equation line, and then we draw a line down to the x-axis, and the value of x is the one that corresponds to that point. So the solution to this equation is x is equal to 5. And we can see that from the graph. Let's test that using our algebra. So we have 2x plus 1 is equal to 11. Now we need to get the x on its own, so let's subtract the 1 for both sides. So we get 2x is equal to 10. Now we need to get the x on its own, so let's divide by 2. And we get left with x is equal to 5. So we can show the solution both algebraically and graphically. As we go further in the course and we learn how to sketch linear equations, you'll be able to combine both of these methods together.